Guys, Mr. Gucci here, and I am going to walk you through the 4.2 notes, the quantum mechanical model. It's a relatively short unit, but it is fairly dense, okay? So I'm going to jump through it, do the best I can to explain it, maybe upload and attach some videos along the way, okay? Your homework for the unit is just going to be to fill out terms and try your best to understand some of the terms and concepts that we're going to cover. Okay, so this unit is called 4.2, the quantum mechanical model, or the QM model, or QMM sometimes, all right? It's a long word, all right? The quantum mechanical model. So when we left off last time, we had just talked about Niels Bohr, who helped recognize that electrons organize around the nucleus in energy levels. These are regions where electrons are allowed to exist, all right? So you could be in the first energy level, the second, the third, all right? And each of these energy levels can only hold so many electrons. So as the first energy level is filled up, if your atom has more electrons than that, then the electrons will fill into the second energy level, and then the third, and the fourth, and the fifth. Every electron must fit into an energy level, okay? That was Niels Bohr's findings, all right? Niels Bohr, all right? And so ultimately, these were how many electrons could be held in each energy level, okay? So the first energy level could hold 2 electrons, all right? Closest to the nucleus, 2 electrons, right? The second energy level could hold 8 electrons. The third could hold 18 electrons. The fourth could hold 32 electrons. Okay, and so forth and so forth and so forth. Filling outward, all right, and like that. I think the next one could hold like 58, something like that, all right? But as you get farther and farther away from the nucleus, there's more space for these electrons to spread out into. And it's important to remember this, right? Like electrons are attracted to the nucleus because electrons are negative and the nucleus is positive, right? And opposites attract. But while the electrons are attracted to the nucleus, they repel each other, right? Because they're negative. So 2 electrons, while they want to be close to the nucleus, they also don't want to be too close to each other. And so as a result, they will end up spreading out just so that they don't crowd each other. Okay? Now, while Niels Bohr's model did do a lot to explain the behavior and characteristics of atoms and how they behave chemically, they didn't explain everything. And there were a few pressing questions that just could not be answered until this gentleman named Erwin Schrödinger came along, right? Erwin Schrödinger, all right, 1926 Germany. He invented the quantum mechanical model. He discovered it, all right? And this is like the first case in which I can give you a discovery that a scientist made, but I can't really go into the experiments because much of it was mathematical and at a level that even exceeds what I'm capable of. All right. So we just kind of have to trust on fact here. And if you want to open up the Wikipedia page to figure out how he came up with this, or maybe find a YouTube video, I'm sure it'll be an interesting watch. I'm sure someone like Hank Green, could do a good job of explaining it. Okay. So what Erwin Schrödinger discovered is that electrons, these energy levels, are not neat little circular shapes, but in fact that the electrons organize into these weird cloudy regions where they are able to exist close to the nucleus but spread out from each other, called probability clouds. All right, we call them probability clouds because this is a region where the electron is probably going to be most of the time. If you look at these little pictures here, these give examples of some of the probability clouds that electrons can exist in, right? The lighter the color, the more likely you will find an electron in that region. And what you can see here is that these regions, like the nucleus is in the center, all right, these regions where you'll find electrons, they are as close as they can get to the nucleus, but they're spread out from each other. There's always a little region where you're not going to find an electron because the electrons repel each other. All right. And so he was able to figure this out and start to develop pictures, actual images of the arrangements of these electrons. And this is where, like, if you go into AP physics, it gets really complicated. All right. But I think fascinating personally. All right. And based on the shapes of these electron clouds, we can actually start to get real predictive models of how electrons work and therefore how atoms bond together. So again, while many aspects of Bohr's model helped explain atomic behavior, there were some unexplained phenomenon regarding patterns in element behavior, as well as there were some science showing that you can't have electrons in perfectly circular orbits. They would eventually decay and break down over time and collapse into the nucleus. So we went from Bohr's model to this much more complicated and interesting thing called the quantum mechanical model. And just so you know, with this word quantum means a very, very small thing, and mechanical just means like physics, interaction. So basically this is the physics of small things model. As you get older, you will find that a lot of super complicated terms in science and medicine are just basic words turned into Latin and Greek. And I personally think that we should think about it that way. It helps demystify things, okay? So again, these are pictures of some of the clouds of electrons around the nucleus. The lighter colored, the more likely you will find electrons in those clouds, okay? So again, quantum mechanical model. Electrons occupy weirdly shaped probability clouds, not these perfectly circular orbit. All right, each energy level. All right, these energy levels still exist. They're just not circular. And each of these energy level contains one or more of these weird shaped clouds in which the electrons organize. So energy level 1 has a weird shaped cloud. Energy level 2 has a few weird shaped clouds. Energy level 3 has even more weird shaped clouds, and so forth. Okay? And these patterns do affect the behavior of the elements. Now, probability clouds. Again, this is the space where electrons will probably be. They're zipping around so fast that sometimes they wander or appear outside of this cloud, but the majority of the time they appear inside the cloud. So here's an example, all right? Here's the nucleus of an atom, and here is a picture. If we could do like a shutter quick flip book, quick picture, billions of times a second. What we are seeing here is where the electrons would likely be around the nucleus. Each picture is like an appearance of an electron, right? So a billion pictures, stack them all together, that's what it looks like. And so with this probability cloud, we would just draw a bubble around the area where the electrons are most likely to appear. All right, this represents where we are 90% of the time going to find these electrons. Okay, and here's an artistic representation of it. Okay, here's the nucleus, and here's where the electrons are zipping around. And you see, sometimes they zip out real far to the outside, but for the majority of the time, right, you will find them, in here. All right, you'll find them in here. Electron are probably going to be close to the middle, probably not going to be on the outside. So we would just draw a bubble around where we would probably find them 90% of the time. All right, it's a cloud of probability. Now, higher energy electron levels are farther from the nucleus and have room for more electrons. Once again, this is just like what Bohr said. All right, these energy levels exist, and the farther away we get, the more room there is for electrons. But where Niels Bohr went wrong was these are not circular. Okay, so we got these sublevels. We got these energy levels. We divide them into things called sublevels. These are smaller groups of electrons that each energy level is broken into. So for example, right, so here we go. We got this diagram right here, okay? The first energy level can hold 2 electrons in it, and they appear in just a group of 2. So there is just one weird shaped cloud that makes up the first energy level, okay? The second energy level holds 8 electrons, but they are comprised of a group of 2 electrons and then another group of 6 weirdly shaped electron clouds. Okay? Then the next energy level, which has 18 total electrons, is a group of 2 electrons, another group of 6, and another group of 10. So we see each energy level that we have. We not only have smaller size cloud, we have progressively bigger electron groupings because there's more space the farther out we get from the nucleus. Okay? And then the fourth energy level holds 32 total electrons, a group of 2, a group of 6, a group of 10, and a group of 14. All right? In this big, complicated looking cluster of electron clouds, these different sublevels. Okay? So you'll notice how every energy level has a grouping of 2 electrons. They have one little group of 2 electrons as part of that level. All right? That sublevel that has 2 electrons, we call it the s sublevel. This is what the cloud looks like that contains 2 electrons. It is just a spherical shaped cloud. All right, a spherical shaped cloud. We call it an orbital. All right, that's just a pair of electrons that make up a small cloud. So this sublevel just contains 1 pair of electrons that make up a small circular cloud. That is what the s sublevel looks like. Okay, so here's what it looks like. Okay, an artist's representation of the s sublevel. All right, it's just a circular sphere, a cloud of a pair of electrons just zipping around together. Okay, that is what the group of 2 electrons looks like. Now, if we go back up to this chart real quick again, we see that starting at the second energy level, each of these levels has a cluster of 6 electrons in it. All right, they also have a cluster of 6. Now, this cluster of 6 electrons is called the p sublevel. All right, the p sublevel. It contains 6 electrons. All right, it's made of these 3 dumbbell shaped clouds. And I just got some balloons ordered from Amazon. I'm gonna do some balloon animal art to show you what this looks like. But this is what the p sublevel looks like. This is what this is what the clouds, the probability clouds of electrons look like for that cluster. Okay, and here's an artist's representation. Okay, here's an artist's representation of the p sublevel. Okay, it looks like this. All right, it's weird. It's like a dumbbell shaped. Okay, just electrons like zipping around. Figure 8 style. Someone's over here. Someone's over here. All right, yeah. But then there's like another one that's oriented this way, and another one that's oriented this way. So it's like 3 interlocking dumbbells. That is the p sublevel. Okay. Then we got the d sublevel. This is what a cluster of 10 electrons looks like, and basically it's made of 5 clover-shaped electron clouds interlocking together. The farther away we get from the nucleus, all right, the more space there is for electrons. And also, the clouds are going to start to get more wonky looking as electrons try and find little crevices to exist in around the nucleus where they can be close to the nucleus but spread out from each other. And you can see these 5 interlocking clover shapes, all right, these 5 interlocking clover shapes, they are allowing a little space for each of the electrons to exist so that it's not crowded. Okay, again, here's an artist's representation of what one of these clover-shaped D sublevel looks like. And there would be 5 of these things interlocking, all right? 2 electrons in a clover, 2 more electrons in a clover, 2 more in a clover, 2 more in a clover, and then 2 more in a clover for a total of 10, okay? There's an F sublevel that contains 14 electrons, but at that point it's just getting like real funky looking, all right? It's made of 7 weirdly shaped clouds that all interlock to form the F sublevel, and that appears starting in energy level 4. Okay, and so what does it look like all together? Okay, Bohr thought that these are all just like circular shells like this, but he was wrong. Okay, here's what it looks like. Okay, the first energy level is just a circle. All right, an s group. All right, 2 electrons. The second energy level is made of a circle and a set of these clover shapes for a total of 8 electrons. The third energy level is made of a circle, a set of clover shapes, or a set of dumbbell shapes, and a set of clover shapes, all right? It gets real complicated. Then the fourth energy level exists that is made of all these weird shaped clouds, all right? So that is how the electrons actually look around the nucleus. It's complicated, but it's kind of cool. We're going to work on it more in the next unit, all right? Good luck, everyone.